All right, so today we're going to be talking about multiplying and dividing rational numbers. Right now we're just going to be talking about integers though, so it shouldn't be too hard. So to review, in elementary school you modeled multiplication in lots of different ways. You did arrays maybe where you created a box. All right, some of you guys did like 56 times 42. And so then, like, you know that 40 times 50, and like you solved this, okay? Maybe you did some skip counting, maybe on some number lines, maybe you used blocks or chips, okay? But this is basically what you learned. You learned that the first factor tells you how many groups you have. The second factor tells you how many units are in each group, and your product, or your answer, describes the total with which you end, okay? Now, I have a video clip, okay? And if you're in the notes on Canvas, you can just click right there and you can watch the chip model. Right now, I'm just gonna go over it in person. So, in class, we're gonna use chips that have a yellow side and a red side, okay? Yellow means positive, red means negative. And each chip stands for 1. So we're going to go ahead and we're going to look at this. So 3 times 4, that's saying that we have 3 groups. Okay, so 1, 2, 3 groups that each have 4 positive chips. So 1, 2, 3, 4. 3, 4, 1, 2, 3, 4 for a total of 12 positive chips. Okay, well this one, we have 3 groups. 3 groups of 4 negative chips. Okay, so I'm going to draw my 3 groups again. 1, 2, 3, and this time I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 negative chips. So for a total of negative 12. And here I can draw my box a little bit better than that. Okay, well, what happens when we have a negative sign out to the front? We can't have negative 3 groups. That's weird. What does that even mean to have negative 3 groups? Well, we can actually think of this negative as opposite. Okay, and we can think of this as the opposite of 3 groups of 4. So we can draw our 3 groups of 4. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, which we know is 12, but we want it to be the opposite of positive 12, which is actually negative. So all these chips become negative. Hence why we get negative 12. Okay. For our last one, remember this means opposite. Three times negative 4. Okay, so we have 3 groups of negative 4 chips. 1, 2, 3. And we're given 2, 3, 4. So here's my 3 groups of negative 4 chips. That's what's inside my parentheses. Well, I want the opposite of that. Okay, so I know that this is originally negative 12, but I want the opposite, so I'm going to go ahead and flip them over to the positive side. Once I fill all these in with my positive color, I realize that instead of it being negative 12, it's actually positive 12. Okay. So that's how we do the chip model. You can always look at the video for extra help if you need. So next, if we were doing this in class, we would click on this link and we'd go ahead and we would look at why is a negative times a negative a positive. As you could tell up here, we had 2 negatives, negative 3 times negative 4, and it ended up being a positive. But why does that happen? Okay. Well, if we were to click on this little link, it gives us quite a few examples, and I would encourage you to click on the link and look at the examples. Remember, it's just on our class notebook. So when you go to Canvas, you're going to click on class notebook, and it should be there. Okay. So let's see. I'm actually going to get rid of one of these. So one of the examples is an English example. So when we say do not eat, this means has one negative word. Do not eat. That means we don't eat. But what if we say do not eat? Well, we have two negatives, so actually what that means is do eat. It means the opposite, or the positive version. Okay? So in English, two negatives really does make a positive. Another example is that when you take away a debt, your net worth increases. I love using money as an example because it's such a real world thing. So when we take away, that's negative, right? When we take something away, it's negative. And a debt is also noted with a negative sign. Well, our net worth increases, so that's a positive. So a negative, and a positive. Now remember, net worth is just how much you are worth, financially speaking, not morally speaking. Okay, well now we're going to move on to dividing. Okay, there's two ways to divide. There's partitive and measurement. I'm going to draw a line right down here. This is going to be our partitive side. This is going to be our measurement side. And you guys will see that partitive is better in some cases and measurement is better in the other cases. Okay, I'm just going to go ahead and draw lines so that we have these separated. So partitive just means that we have a certain number in a group and we're going to part them into different groups. Okay, so in this case we have 12 whatever. Maybe we have cookies, maybe we have candies, who knows, but we have 12 of them. And we're dividing it into the opposite of three groups. Okay, so remember, we don't know what negative three groups means. We're just going to say that this is opposite. Okay, and we could even do commutative property. So we could do, actually we cannot do commutative property. We're just going to keep it this way. Okay, basically we want to split it into three groups. So 1, 2, 3, but we want it to be opposite of what's inside those groups. So instead of there being a positive 4 in each group, we now want it to be negative 4 in each group. So 12 divided by negative 3 is negative 4, because the value in each group is negative 4. Well, if we were to do it on a measurement scale, we would probably have some sort of number line labeled from 0 to 12. Okay. I'm just going to quickly write in a couple measurements here. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, there we go. So for measurement, we have 12, or a positive 12, and we want to divide it into three groups. Well, each group, if we divided it into three groups, would have 4 marks in them, right? 1, 2, 3, 4. 1, 2, 3, 4. So each of them would be sectioned into 4. Okay. Well, we want the opposite of it, so then we'd have to flip our number line. So we would get, So we'd have the opposite, or -4. Okay. Now, for the measurement one, this doesn't really make a lot of sense. We probably would not use measurement for this one. Okay. However, we would use partitive for this one. That one's a little bit easier. Okay, let's go ahead. Let's look at -8 divided by -2. So we're going to start off with -8 pieces of whatever, maybe candy. Who knows? Maybe they're Skittles. Skittles sounds good. And we want to divide them into -2 groups. Well, what does that mean? I don't know. We're going to divide it into 2 groups, though. And remember, we can think of the negative sign as being opposite. So we're going to divide it into 2 groups and then do the opposite of what's inside of it. So we have negatives inside of it, and we want to do the opposite of it. So we're going to turn them into positives. So really, there is a +4 value. That one was a little difficult to wrap your head around, to be honest. Not going to lie. Whereas with the measurement, okay, say we're on a scale of 0 to -8 because that's what we're starting with. That's our starting number. So we have -4, 6, -2. Okay, now we have -8 and we want to divide it into pieces of -2. Oh, well, guess what? That's really easy. Whoa, sorry guys, my pen is like freaking out. Okay. This is a piece of -2. This is a piece of -2. So is this, and so is this. Well, how many pieces of -2 do I have? I have 1, 2, 3, 4 pieces of -2. So that's how I get it. Now, in this case, measurement is much happier and partitive is less happy. Okay, so there's ways that you could show partitive or measurement. Happy or unhappy. Okay. Now for this one, I want you to think, do you notice any patterns? Okay, or have you noticed any patterns between multiplication and division? Okay. Now you should have noticed that anytime you multiply or divide a positive and a positive, you get, well, a positive. Your product or your quotient is a positive. However, if you do a positive and a negative, your product or quotient is a negative. And if you do 2 negatives, your product or quotient is also a positive. So as you can tell, our quotient, -8 divided by -2, ended up being a positive. Interesting. Well, I have a question for you guys. Talking about division, why is dividing by 0 undefined? So oftentimes we know that 0 divided by 5, if we plug that into our calculator, it's going to give us 0. However, 5 divided by 0, it gives us an error, okay? We denote that by putting a line through our 0. This one's undefined. Okay, but how? What does that mean and why? Well, in order to demonstrate that, I'm going to give you guys an example, okay? I want you to think of number families. Okay, and you guys learned about number families when you were in elementary school, okay? Remember, number families are any group of multiplication and division or addition and subtraction that you can do that will give you the same product or quotient. So, for example, 12 divided by 2 is equal to 6, okay? So that means that the opposite is true. 6 times 2 is equal to 12. Well, what about when we have 12 divided by 0? What does that equal? So the opposite would also have to be true, right? Like some random number times 0 would have to equal 12. Okay, can you guys think of any number that would satisfy this equation? I mean, let's try it. Let's try Plugging in 12 right there. 12 times 0 equals, you got it, 0. Well, what about negative 12 times 0? No, that still gives me 0. I can think of fractions. Let's see, 1/2 times 0. I am trying to think of anything and everything that I possibly can, but nope. Nothing satisfies this equation. So we're going to say that the reason why divided by 0 is undefined is because nothing or no number satisfies the equation. Okay, well, let's look at fractions really quick, because I know that we've been talking about integers, but fractions are a little bit different. And sometimes they can seem a little scary, but they're really not, I promise. Okay, so it says explain the quotient 2 divided by 1/3. Will it be bigger or smaller than each term? Remember, 2 is a term and 1/3 is a term. Okay, well, to illustrate this, let's draw something. So we're going to have 2 as our starting. So let's draw 2 cakes. How about that? I love cakes. Sorry that my circles are awful. Okay, and we want to divide them into pieces that are 1/3. Or 1/3 size pieces. Do you see how each of these pieces is 1/3 of our cake? Okay, we happen to have 2 cakes, but each piece is equivalent to 1/3 of the whole. So how many pieces total do we have? Well, we have 1, 2, 3, 4, 5, 6. So we have 6 third pieces. So 6 pieces that are the size of a third. So in this case, it would be bigger. Okay, why? Well, 2 cakes divided into third pieces will result in there being 6 total pieces. Okay, well, what about when we have a fraction first? What happens when we start off with the fraction? Let's go ahead and let's draw, I don't know, I'm going to draw a candy bar. Why not? So this is a full candy bar, but really I just want to focus on a third of a candy bar. And I want to divide this third of a candy bar into 2 equal sized pieces. Okay, so I'm going to divide it into 2 equal sized pieces. So there's this piece and this piece. Well, how big is each piece? Okay, well, each piece is only half of a third, which is 1/6. So in this case, it is smaller. Why? Because 1/3 of a chocolate bar divided into 2 pieces results in each piece being 1/6 of the total chocolate bar. Okay, now we're going to go ahead and we are going to go over long division really quick. So long division, really quick. Actually, I'm gonna revisit long division afterwards. Let's write some expressions. So for these expressions, I want you guys to write division expressions.
What is that?
So anytime that we have a negative, I'm going to underline it in red, and a positive is going to be blue. So Keith borrowed $30. So we know that this is going to be negative 30. Well, he borrowed the same amount of money from 5 different friends. So we have a total of 5 friends. Okay, you can't have negative friends. Maybe some of you guys think that way, but I promise you, you don't. How much money does Keith owe each friend? Okay, so this is the other one that's going to be negative. So we're going to start off with he's in debt $30. And he divides that debt equally amongst his 5 friends. This is how you would write the expression. You can easily solve that. Okay, and you would find out that he owes $6 to each friend. But right now we're just looking at the expression. Okay, so let's go ahead and underline this again. Siegfried borrowed $4 a day, so that's negative 4, until he had borrowed a total of $88. So he's now in the hole, negative 88. How many days did he borrow money? That's what we don't know. You can't really have negative days. It's going to be positive. Okay, so for this one, I would probably write that he had a total of negative $88, or he had borrowed a total of 88, and he divided that by $4 a day. So this is our expression. You could easily figure out that he borrowed money for 22 days. Okay, but again, we just want to focus on the expression. All right, so now let's write some context for the following expressions. So again, let's think of what the negatives can be. So this one starts off with a negative sign. So that could be borrowed money. That could be altitude. Okay, think about like depth underwater sort of a thing. It could be temperature, even though negative 70 is, I don't know that that's even livable. Okay, so I'm just gonna go ahead and give you my example, and I want you to come up with your own. So I'm gonna start off with some borrowed money. So let's just go with Keith again. Keith likes to borrow money. Keith borrowed $70 from how many friends did he have? 2 friends. Okay, assuming that they're all equal, or that he borrowed an equal amount of money. How much money did he borrow from each friend? Ta-da! That's pretty easy. Okay, well, what about this second one? Mrs. Trujillo, this one starts with a positive. Well, let's think about it. So that's an asset. Okay, that could be money that we have, or that could be net worth that we have. It could also mean distance. It could mean temperature, right? Because temperature can also be positive. In fact, for my example, I think I'm going to use temperature. So let's just say on December 12th, it was 30 degrees. And I just like December 12th. I don't know why. Okay, let's see. The temperature dropped 3 degrees. Okay, so remember when it drops, it's a negative. So that's why I'm dropping it 3 degrees. So it dropped 3 degrees each day until it reached 0 degrees. How many days did the temperature drop? And 0 degrees is freezing. Okay. I want to see which contexts you guys come up with, so I will be doing a notebook check. Really quick, let's go back up to long division. I want to spend a little bit of time on long division. So we briefly covered long division, and I told you guys you can totally use a calculator to do this. I'm just going to show you how to set it up. Our numerator is what goes inside our little house, and our denominator is what goes outside our little house when we set it up. So for example, we have 4 divided by 11. That's how we would set it up. So 11 can't go into 4. It goes into 4 0 times. However, if I were to add a decimal point and a couple zeros, I'm just going to add 4 zeros. Why not? Okay, I'm always going to line up my decimal point. Now we're going to try one more time. 11 goes into 4D. Okay. How many times? Well, it goes into 43 times. 3 times 11 is 33. Go ahead and subtract that. I get 7. Bring down the 0. Well, 11 goes into 76 times, right? And we get 66 with 4 left over. Bring down your 0. 11 goes into 40 3 times, and we get a remainder of 7. Bring down the 0. I'm starting to notice a pattern. 11 goes into 70 6 times for a remainder of 4. And we could keep going on this pattern forever and ever and ever, or we could just write it as 0.36 repeating. Okay. All right, so anytime that you have a long division where the numerator is smaller than the denominator, you can always add a decimal point and some zeros to figure out the decimal expansion. Again, you guys will have access to your calculators, though. Let me know if you guys have any questions.